Okay, let's give you guys some more practice. So determine if this series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, we are going to use the ratio test. So when it comes to the ratio test, we always need to compute this value here. So we always need to take the absolute of the next term divided by the current term. Well, n is moving from 2 to infinity. So this will always be positive. This will always be positive. The whole thing will always be positive. So we don't really need the absolute sign. So now your an plus 1 will be this, and then divided by an. Well, dividing by an is the same as multiplying by the reciprocal of an. So that will then give you this. So now tidy this up. So looking at this, if I were to give you z to the power of n plus 1, that's the same as z to the power of n times z to the power of 1. So you've got your whole thing here. You've got your whole thing here to the power of n, and then your whole thing here to the power of 1, So this whole thing here will then become this. Now tidy this up again. So group these two together. Group these two together. So you've got to the power of n to the power of n. So you can rewrite it as this. And then you've got your n plus 1, n. So your n here times this. So that will then become this. So now comes the hard part. So here you've got one block multiplying another block as n heads towards infinity. Let's try and understand this block here. So just try and understand this block here at the moment. So your natural log looks like this. N is here, so that's this bit here, and then n plus 1 will be slightly higher. So when it comes to the natural log graph, it's always increasing. It is strictly increasing. So n plus 1 will always be slightly higher than n. So let's just imagine this to be 3, and let's just imagine this to be 4. So the ratio here would be, in our case, in our made up scenario, it will be 3 over, remember n plus 1 will be slightly higher, 4. Let's just say 4. So you've got this ratio here, and then to the power of let's say 7. So what this means is 3 over 4 times by itself 7 times. So because this thing here is less than 1, it's going to get smaller and smaller. You see, this power to the power of 7 is driving this 3 over 4 smaller and smaller, because 3 over 4 is less than 1, and when you times by itself many times, it's just going to get smaller and smaller and smaller. So this n here will drive the whole thing smaller and smaller. But the thing is, the ratio here will get bigger and bigger and bigger. So here, the reason why this is complicated is you've got one bubble to the power of another bubble. This bubble here wants to get bigger and bigger, but then this thing here, don't forget, this bubble here, the ratio of the two is always less than 1. It's definitely going to be less than 1 because, hang on, natural log is always increasing. Your n is here, your n plus 1 is here. This number will always be bigger than this number, so it will always be less than 1. The ratio here has got to be always be less than 1 because this number here is always bigger than this number here. So that's like me giving you 7 over 8. This is bigger than this. It's always, this ratio here will always be less than 1. But the thing is, it's climbing. So the limit of this thing here, the ratio is actually heading towards 1. But so here you've got a bubble here, and you've got another bubble here. The thing is, this thing here wants to climb. It wants to climb towards 1. But then because this bubble here is less than 1, let's say 0.93, and then you've got to the power of, let's say, 7, then that means 0.93 times 0.93 times 0.993. This thing here is making making the 0.93 get smaller and smaller and smaller. But the thing is, this thing here wants to get bigger and bigger and bigger towards 1. The biggest value that this thing here could be is 1. The reason why this is complicated is because you've got this thing here that wants to grow towards 1. And then you've got this thing here that tells you to times by itself, meaning the whole thing will get smaller and smaller. So you've got, on one hand, you've got this thing wanting to go up towards 1. And then you've got this thing here wanting to drive the whole thing down. So you've got a constant battle between this growing and then this decreasing. So this thing here is actually quite hard to evaluate. But what we do know is that the highest value that this thing here could be, well, the ratio itself is heading towards 1. Because when you get n natural log of n plus 1, when you get natural log of n divided by natural log of n plus 1, it wants to head towards 1, but it will never get to 1 because natural log is always increasing. So what I'm trying to say here is that the highest value that this block here could be, let's just say it's 1, because this thing here is never ever going to get to 1. So the highest value this thing here could be is 1. So what you can say is that, well, we are going to use the squeeze theorem to try and evaluate this as n heads towards infinity. Well, we know that the biggest value that this block here could be is 1. So let's just imagine this whole block here to be 1. So the highest value that this thing here could be, well, the highest value that this block here could be is 1. So you've got one thing times 1. So the highest value that this thing here could, the highest value that this whole thing here could be is this. So if the highest value that this block here could be is 1, then you can say that this whole thing has got to be less than or equal to this. So basically imagine this to be 1 here. So this times 1, that's this thing here. And then so you can say the whole thing here is trapped in between 0 and this thing here. Well, the limit, so this is really like us using the squeeze theorem. Remember the squeeze theorem is that if you have one function f of x, and then you've got another function g of x, and then h of x is always trapped in between the two. If the limit of the, well, I hope you can see that I hope you recognize the squeeze theorem. You should know the squeeze theorem by heart. So this is like the squeeze theorem. This thing here is always trapped in between this and this. Well, the limit of this, if you think about it, the limit of this is 0. So you've got something that you know nothing about trapped in between 0 and 0. So the limit of this will have no choice but to have the limit from 0, because this is 0, and this is always trapped in between the two. So the limit of this thing here is 0. So looking at the ratio test, we just computed this thing here, and it turns out to be 0, or 0 is less than 1. So therefore the series will converge. So what that means is our ratio, what that means is our series, this series here, will converge. Okay. So let me just briefly glance over it. We used the ratio test. So we needed to compute this value here. Well, we computed this value, and it turns out to be 0. So yeah, it turns out to be 0. So it will mean that the series will converge. Okay.